My research group's main goal, purpose, is to make it possible to predict what's going to happen in reacting systems, chemically reacting systems. And we apply that new capability to predict chemical reactions to energy problems. So, for example, there are many different proposed alternative fuels, and my group tries to figure out how those different proposed fuels would burn and how they would work in air pollution and so on. And then we can use that to assess which of the new alternative fuels would actually be the best. And this is important to do because to experimentally test a new alternative fuel means you have to make it first in pretty big quantities, and then you have to do a lot of engine testing and a lot of other experiments. And it's very expensive, and so because of that, it's a big inhibition in the development of new fuels, the fact that they have to do everything experimentally. So since about the late 90s, it's been possible to actually compute chemical reaction rates on a computer by solving the Schrödinger equation. And by doing that, then we can actually predict how things will react without having to do the experiments. And so we can kind of pre-screen a lot of possibilities and find out things which are not going to work out and focus our attention on the systems that have a good chance to succeed. We write computer programs that solve the equations. It's a very complicated set of equations for a chemically reacting mixture. And so we write software that assembles the equations and then solves them for particular systems. And then we use the chemistry models that we get in engine simulations and simulations of other devices to see how well things will work out in practice. And it's a lot of fun. It's a very exciting area to be in because historically it was impossible. Historically you had to, if you wanted to study chemical reactions, you actually had to do the reaction in a laboratory. And so to be able to actually change and do predictive design on a computer is a really major transformation in that field. I think that just the capability to be able to predict reactions, it opens up so many doors. Most of the commercial technologies in the chemical industry were developed back in the 50s and 60s, and they had slide rules. They had no computers, they had kind of primitive chromatography, and they were smart guys, they figured this out, but there's no reason to think that any of those systems are actually optimal. They just got to work good enough that it was economical at the time, and that's where they went. But now you can go back and re-examine a lot of those processes and say, boy, there's got to be a more economical, less environmentally harmful way to make those chemicals. And if you actually can understand in detail how that process works, then you can say, and the computer says if I change this, then I should get better yield, I should get less pollution, I should use less energy. At the present, when we want to try to predict what happens in the chemical reactions, we actually, as humans, have to be able to guess what are the possible reactions that could happen. And we have a computer program that kind of takes that human guess and systematically applies it. So we're able to figure out maybe there's several hundred reactions happening, and we had to know that maybe there were 20 types, and then the computer will find the rest of them. But sometimes we don't know. There's actually new chemistry out there that people never discovered. So I think that the really exciting possibility is you could actually have the computer go search for the reactions. So I don't know if you know, if you ever took organic chemistry, they have all these named reactions, so-and-so's reaction is other guy's reaction, and what's his name's reaction. Well, if you could just have the computer just go find the reactions, you don't need to have some Nobel Prize winner to go find the reaction for you. You can actually just tell the computer, okay, I'm putting these chemicals together, what's going to happen? And the computer can exhaustively find out all the different possibilities. And it's theoretically possible to do it. And so we've been, I'm very excited to pursue that and try to figure out how to automate it. So I just start the job, it says, these chemicals are in the pot, what's going to happen? And just, not have to have an expert human to coax it along, but just let it go and it'll just tell me, okay, this is what's going to happen. And that's what I think really the users eventually, if you're working in a company and you want to make something, you don't want to have to be an expert in chemistry and know every kind of reaction. You want to just be able to say, go get your cup of coffee, come back. The computer will tell you, yep, that proposed product's going to be great, you're going to make a lot of money, or it's going to tell you, nope, it's going to clog up the reactor with a bunch of char. And then you'll know whether or not it's a good idea. That's what we're trying to get to. And I think it's happening. So back in the 70s, there was a big energy crisis in this country, and the MIT Chemical Engineering Department wrote software called Aspen that allows you to quickly assess whether a proposed chemical process is a smart idea. But unfortunately, it can't predict anything about reactions. So it does all the other stuff. It does separation and mixing and pumping and stuff like that. It does great. And so I'm trying to add to that the capability of do all the chemical reactions as well. So then you could actually just draw a chemical plant on your computer screen, press go, it'll tell you, how much money you'll make tomorrow and what product you'll get and how much pollution you're going to make, and you can just say, oh, that's not good, let's change the design and try it again. And I think that's really where the future is.